lattice extra library. So we needed to change all of the character columns into factors.
Oh, hey.
Hey,
How's it going?
good. What are you doing?
What do you mean?
What are you eating?
Oh, this. Yeah, I heard you're supposed to eat a credit card every week.
No, is that right? I think you eat a credit card's worth of plastic every week.
That makes more sense. Better cancel those new credit cards. Did you hear that study about microplastics? I only heard about it last year, but it's really from 2018. So what happens is when companies make plastic products, a bunch of teeny tiny particles get into the air, the water, even your food. And when people try to recycle plastics, they have to shred them up, they have to melt it. Even more little plastic particles get into the air, water, even your food. So this study just came out showing that a certain type of microplastic can lead to heart disease deaths. Other studies have shown that it might even decrease sperm counts. So when I was like 12, one of the best meals ever was when my parents were out, about once a month. I got to eat a TV dinner, I got to watch TV all night. I got to microwave these nasty spongy chicken nuggets or Salisbury steak, maybe some mac and cheese on the side, maybe this little spongy brownie. It came in these little plastic containers and it had this little plastic film on top, and the box said to microwave it for like 3 hours. And then the plastic melted all over the food and it was so good. Now 20 years later, I got no sperm. Maybe I've got at least a few. I've got 2 kids. Welcome to Data Viz with Class. I'm Caleb Class. Today we're talking about recycling. Do you recycle? Did you know that a lot of people in America and around the world don't even have access to recycling? And when you do recycle, where does all that stuff go? That's one question we're going to look at today by making a graph. When we have a data set that says this type of stuff might go here, a good type of graph you might want to make is called a Sankey diagram. So when we have a bunch of categories and we want to say how much of each category goes where, we can use curvy lines of various widths connecting what to where it goes. This is not the type of graph that most people need to make all the time. I haven't made one in about 5 years, and also this data set is pretty complicated, and also the boss is breathing down my neck. I need to be done in less than an hour. So we're going to use GitHub Copilot to help us out. Let's start the clock. If you've never used GitHub Copilot before, you need a GitHub account. Check the link in the episode description. There's a free version that limits how much you can use it per month. There's also a paid pro version, but students and teachers get that one for free. We want to go to our tools, then global options, find the Copilot window, and then we'll just click enable once you have GitHub Copilot. I'm signed in, so I'm ready to go. You have the choice to do automatic suggestions or manual suggestions. I'll keep it at automatic, but I will increase the amount of time, say a few seconds, because I don't necessarily need suggestions for every single line. I will start a new script, and then we need to load our data. Now, I've only tried Copilot a few times, but I think it might be good in this case, since we're trying to do something pretty complicated. Whenever we're using these types of tools, one super important thing is to actually look at the code it gives you and look at the results it gives you. Sometimes it gives you a nice graph that looks good, but it didn't actually use the data that you wanted to do, or didn't actually make the calculations that you wanted it to make, and then it's actually showing misleading data. So this type of tool can help you get stuff done faster, but you have to look at the results closely. I've got an Excel spreadsheet published by the US EPA in 2020, and it shows how much of different types of materials were generated, as well as how much was recycled or sent to a landfill or combusted. So I'm going to check my files window, and I'm going to attempt to import the data set. And now it's only going to import the first sheet, the materials generated sheet. So we want this, but we also want some other data in here. How much was recycled, how much was combusted, how much went to the landfill. But we can see we've got various types of products, and we've got how much was generated each year. I just want to look at the 2018 data. So what I'm going to do, instead of trying to separately load in each sheet individually, I'm going to see if Copilot will help me load in the first 4 sheets of this data set automatically. So it's given me a few comments that are not super useful, but we're going to see if it gets to what I want, and I do not trust it now, so I'm going to do it myself. Well, that's how it goes sometimes. If you know how to get it to do this, let me know in the comments. Alright, but it's not too bad. It's just 4 sheets. There is definitely an sapply function we could just do here, but I don't have time for that. I'm going to do it manually. So, we're going to set this up as a list object. We are going to give each part its own name in the list object. So now we have the data, so now we have the generated data frame. We have the recycled data frame. We're just copy pasting. Again, an sapply function would be much more impressive here, but we're doing the minimal amount of thinking today. We are just going to get this done. Okay, so I could even, if I wanted to, I could use the indices of each one, but I'm going to use the names just to make sure I get the right ones. All right, and the names are all the same. We just need to change generated to recycled, combusted, or landfilled. So that's easy enough. So we are going to copy paste 2 more times. Right, and we are going to look for whatever the heck I did wrong here. Now, something about this thinks it is a zip file. All right, so it does not see materials combusted. Let's take a look. Did I spell it wrong? Material combusted. So that one is not plural. We did it. Now we have all of our data. We are ready to go. So we can look at, again, we've got our materials generated. We've got paper products, glass products, metals, plastics, rubber. We even have food waste and yard trimmings. And then we can check how these match up to our other data frames in this data set. And if we look at materials recycled, we will see we maybe even have a few different things. So it doesn't match up exactly. This is very annoying. I don't think Copilot can be very helpful here either, but let's give it a try. Merge the 4 data frames in this list by materials column. Let's see what it gives me. All right, this is looking good. Let's see, it is a capital M, but that was my bad. And I don't know what else it's going to do. Okay, we're going to replace our NAs with 0, which is probably a good idea. All right, let's see if this works. So we're taking our list. We are doing a full join, which is merging 4 separate data frames by the column. So it finds where it's the same type of material, and then it squishes those together. So that's great. That's what we want. So let's see if it works. All right. So Copilot thinks I should be doing more. We want as numeric. That makes sense. And what else does it think we should do? So now I guess it's dividing by 1,000 because it wants to. Why don't we stop there? And let's try to run it. So I'm going to hit escape to not run that last thing I started. And we're going to run this. We did not load in the tidyverse. If we do that, we should have something. Let's see what it gave us. That was slightly quicker than it would have been just looking it up. Now, the issue here, I think that's okay, because what we want is just 4 columns from 2018. And then we are going to rename them in order of what the different data frame was. So I think this is going to work out very nicely. Only keep materials column and the ones from 2018. So all we need to do is some sort of select function. Oh my goodness, look at all that. That is too much. So this is the type of thing that can be overwhelming. When you see it give you 10 lines of stuff, you could just run it and say we're happy. I don't necessarily trust that. I definitely want the columns with 2018. I don't think they end with 2018 though. I think they start with 2018. Yes, as you can see. So I'm just gonna not trust the rest of this because I don't think this is gonna work. Let's see what it would give us if we did ends with 2018. Yeah, nothing. Nothing ends with 2018, it starts with 2018. So let's give that a try. And then head starts, head materials df. And I'm going to be lazy and just rename those 4 columns manually. So call names of materials df is, oh, and we'll skip the first one since that one's just fine. C generated, then recycled, combusted, and landfilled. And it got it right. So thank you, Copilot. Okay, now if we look at it, head, column, head. Actually, let's view. All right, now we're getting pretty happy. We got some blanks for some reason. So a few things we need to do to get it ready. Then we're in pretty good shape. We are going to remove the ones that have 0 generated and some recycled because we need what percentage of generated got recycled. If we have 0 generated, then we have no idea. We are also just going to use the categories. So when it says all these different types of metals, I just want total metals. It'll get too complicated without that. I might also remove some of these minor categories. Maybe we stick with the major product types. It is certainly useful to look at food waste and even yard trimmings. That is a lot of yard trimmings. But let's keep it simple for today. So rather than getting rid of all the zeros, I'm just gonna select the rows that I want. So I want paper, I want glass, I want total metals, I want plastics. Let's stick with that. That'll be easier. Let's see if Copilot can do that for me. Filter for only paper, plastics, total metals, and I forget the last one, glass. Now we're gonna see if it can figure out the column. I don't think it'll know the column names because that is not in, yeah. So it doesn't know. So I have to do that myself. That's okay. All right, and I can do a little copy paste from the column names here. That will be just fine. Not the column names, the material types. Okay, so we're getting there. Let's call it the subset. So I will want to pivot longer. Materials in, and I'm just going to copy paste those material names because they're a bit longer. And the last one was products plastics. Oh, look at that. We even got that one. Okay, so we're focusing on the 4 major material types. And let's also pivot longer and see if it knows how to do that. Right, we want to pivot everything except materials. We want to change the names to type of location, say, and the values to tons. And that works just fine. So now let's take a look at what we got so far. Okay, we've got materials, paper, glass, metals, plastics. How much was generated, recycled, combusted, landfilled, just for 2018. So now is the moment of truth. We got what we need. Let's see if it can make a Sankey diagram for us. Okay, so it helped us a little bit. Still took us 22 minutes to get the data ready for a graph. But let's see if it can get us to that graph quick. Make a Sankey diagram connecting materials to type. And I don't know if type is the best name for that, but let's leave it at that for now, because we're gonna label it anyways, so I think it's fine. GG alluvial, let's see if I have that. Nope, I don't. I think there's one called GG Sankey, but we'll trust it. I don't actually need to call GG Plot because I called the tidyverse. And I don't want to call it a second time. Alright, so let's see if it can get us there. Materials subset, we're going to send it into... Alright, let's take a look at what is suggested. Axis 1 is materials, axis 2 is type. The Y value is the amount of tons. That makes sense. That's going to be our height. So we're going to, from materials to type, so materials to where they go, and how much of each is moving along is our tons. So that sounds good. We're going to fill by type. That makes sense. We could also fill by material, but this is going to fill by where it goes. So that's reasonable. We said width. We're doing some fancy stuff. I do not know what geom stratum is. I'll have to look that up. Let's look that up real quick. Geom alluvium. Should actually know what that is. So I think the alluvium is our little ribbons. So these are the chunks at each axis. So that makes sense. And then we're giving it a lot of little types. So this is feasible. I did not call the library. And now when we do it, we get a graph. And this is completely functional, and that is thrilling. So this would have taken me quite a while. I got this step done in 3 minutes. So that is great. Now we need to look at it carefully, because it doesn't look amazing. So one thing we do need to do, our 4 categories are kind of a mess. We've got products, metals, total. That is very hard to read. What else? So when we look at this closely, we see it did what makes sense. It took combusted, generated, landfilled, recycled, but it put them all on the right. Generated should be on the left. Okay, so that is just one thing that it would not know any better, but we need to notice this. We need to figure out how to fix that. So potentially the amount generated is equal to combusted, landfilled, recycled, but that's not necessarily the case. So what we should do, we need to go back a bit, and we are going to look at our generated column, and we will add an other column that equals generated minus recycled minus landfilled minus combusted. All right, so all we need to do here is do materials df other is materials df generated minus all the other things. All right, so we're gonna make it. So if you showed that graph that Copilot made you, you'd look pretty silly. But if you look at it carefully, then you know what to do. It still saved us time, so we're still happy. We just need to know what we're doing. Okay, so now let's look and see if other is 0 or if it's more than that. Right, other is 0, so we don't need other. So that is great. Okay, so now we do not need the generated column anymore because the total is going to be generated. And then we see how much of generated goes to the three other things. So how much of the plastic generated goes to the landfill, goes to recycled, goes to combustion. Okay, so I'm going to remove the other column and I'm going to remove the generated column because we do not need that anymore. And then the last thing I will do is rename our materials types so they are simpler. You'll notice I'm going back and forth between the different types of pipes. They both work. So we just need to select recycled, combusted, landfilled. Now we look at that. And we've got our three columns. We can filter just like before. And actually, before we pivot longer, I'm going to rename the materials. Materials subset $materials is, and there's a dplyr way to do this, but I'm just going to do it the lazy way. C, paper, glass, metals, and plastics. And now we can take that and pivot it longer. All right, let's take a look now. It doesn't like that. Let's see what we did wrong. And we can see that I forgot to select the materials column here. Very silly. So now we need to run a few things again. I think we got it. Pivot longer. And this is exactly what we want. So we do not need the generated type anymore because the total of the three locations that it's going to is how much was generated. So this should give us exactly what we want for our Sankey diagram. And let's see if it still works. I do not think we need to change anything. I think we can just run it just like before. Much better. All right, so this is a default diagram. It's not the most amazing thing in the world, but it gets the job done. So we are happy. We got it done. 32 minutes. This is excellent. So let's see if we can take 15 minutes. We can make this amazing. I don't think we need the little labels for materials and type. I think those are very self-explanatory. I don't think we need the color axis for the type. And I don't necessarily need to show how many tons it is. And we don't need that title. So there's a lot of things we could fix about this. We can make those bars much prettier. Geom stratum, I think those should have a fill. So let's see if we can do it. Yeah, so it's going to be tricky. I'm sure we can do different fills on the left and the right. But some things that I know how to do: theme, legend, position. Equals, oh, except is it none or is it false? Right, so that's gone, that's nice. Remove all axis labels. All right, this should work. Oops, except I need a plus there. All right, so we still have the axis ticks that we do not want. Axis text y equals element blank. Okay, getting a little better. Where's that title? That is a boring title. Let's make it a good title. Not that good a title, but let's just say, where does the recycling go? Better title than Sankey diagram. This is getting much better. I'd like to change the widths of those stratums. I think I can do that right here. We can just kind of mess with it. One is way too wide, about 0.2. And we're just playing, and that is good. Can we add a fill to geom stratum? And actually, we don't even need to do that. Let's just make the fill transparent. And transparency is just like it always is. Alpha equals 0, big money. Oh, that is so close. Except our little, it doesn't go all the way. And why does it do that? Oh my goodness. Oh, and we do have a grid. I couldn't see the grid before. So, we just need to remove grid. That is not the grid, and also not the right number of things to scale it to. I like the purple though, so let's do that. We're gonna make recycled green. We will make landfill purple. And the only thing we have left to do is get the little thingies to go all the way instead of having that box. And that is what we want. All right, this is just the biggest ggplot code thingy that there has ever been. And now the colors are weird. I think that's kind of where we started, but that is good. Let's fix those boxes and we are done. So how do we fix the boxes? We can move this fill equals type up to here. We can change our alpha to make it a bit higher. We are still, we're starting to understand it, but we still have not made it amazing. But I think we're done, because I'm done. And we are gonna get that width back to where it was. Done. 48 minutes, stop the clock. Okay, so there is a ton more stuff we can do if we have time. I don't have time because I got to present this right now, and I'm presenting it to you. So what we can see, we got our materials types: glass, plastic, metal, paper, and how much of each goes to combusted, landfilled, recycled. We've colored it by the different types, and by doing this, if you look at the left, you can pretty easily see how much of each one is going to each place. But then if you look at the right and you kind of look across the whole graph, you can see the proportion overall that goes to each fate, we'll say. So, about even amounts of these things are supposedly being landfilled or recycled, while much less is being combusted. So, one twist to this. Right, this is reported by the EPA. This is just things that were collected by recycling companies. So this does not show the final fate of all these things. I tried to look up the actual data for what happens to things at the recycling companies, and it was not super clear. All the numbers were really rough estimates. So what we would really want to do is we would take the amount that is combusted, landfilled, recycled. Combusted and landfilled, those are done. Recycled, some of those things are actually recycled, but some of those things end up in a landfill. Some of those things get exported all over the world to places where they are theoretically being recycled, but a lot of the time they end up in a landfill in those other countries. So this huge amount of recycled materials, which would be great, is not real. Maybe it's half of that. So if we take this amount that's recycling, maybe a third overall gets put in a recycling bin, which is more than I expected. But I guess that's only of recyclable materials, so glass, metals, paper, plastics. So of those materials, maybe a third of them in the United States get put in a recycling bin, which was a little surprising to me. I thought it would have been less. But of those things, a lot of them end up in a landfill or somewhere else. A giant trash island in the ocean. So fun. Building a summer house there. So, if we had a lot of time, what we would do was we would add a third axis to this, and that would show landfilled and combusted, those are all gone. But recycled, we're gonna split that and show where that actually goes. So here's a way better Sankey diagram. This one comes from the folks at informationisbeautiful.net. Hopefully they spent more than 45 minutes making it because it looks really nice. It focuses just on plastics, but it also shows us all the plastic that has ever been made. So let's see, what would that was as of 2017. So there's been a few billion tons more than this since then. But in 2017, there had been over 8 billion tons of plastic produced. Couple billion of those are still in use. A lot of plastic products that last a long time. Some of them, decent amount. But a whole lot of them get used once, they get thrown away. Theoretically, they get recycled. A lot of them just go to the landfill. Even the ones that get recycled sometimes go to the landfill. So 4 billion tons of plastic, say plastic coffee cup, iced coffee cup. They got bought, they got drank, they're off to the landfill. That's it. Even the plastic that has been recycled, it gets recycled 1 or 2 times, then it's off to the landfill. So overall, you remember reduce, reuse, recycle. When we talk about plastic, we're mostly focusing on reduce, reuse. You go to your giant coffee chain to get your giant coffee, maybe bring a reusable cup. You get some points, you can buy more giant coffees. So hey, we did it. We used Copilot. It definitely helped us out. I think I would have taken, I don't know, another 20 minutes to remember how to make one of these Sankey diagrams. If I took another half an hour, I think I could make it better looking. Maybe I'll post something for you. But a lot of you might have experience. I'd rather you tell me how to do it. Let me know in the comments. Tell me how you do a Sankey diagram. What are your tips? What other types of data would we want for this graph? What other types of graphs might you make with this data? What other types of data might make this a better Sankey diagram? How do you reuse the amount of plastic you use? What's your sperm count? Maybe not the last.